Okay, last hour we finished up by designing our compulsive shopping app. And we did it two ways. We did it with regular if statements nested, and then we did it with else ifs, which looks a little bit better. And so the next thing we need to learn how to do now we've got the design down is how do we implement this in C#? So in my notes, I'm now jumped ahead a little bit to page 9 because this stuff we've all covered already. In page 9, I first talk about the relational operators. Remember, what relational operators allow you to do is compare two values. And those values can be of varying types. Relational operators allow us to compare strings. It allows us to compare numbers. It allows us to compare dates. So they're very powerful in C#. We can compare all kinds of stuff. Pam, can you close that for me? There are 6 relational operators: greater than, less than, and again, if you don't know which one's which, I saw Tim holding up his hands. Less than is the L. L for less than, right? If that helps, knock yourself out. Whatever, if you can't remember which one, look them up. Because if you flip them around, you get the wrong answers. Absolutely. There's a double equal sign. When you're doing comparisons, you have to use a double equal sign to say, are these two things identical? You have to use a double equal sign for that. If you use a single equal sign, you get a syntax error in C#. There is an error in your notes for those of you looking at the printed notes. A little later, about 2 paragraphs down here, it says a common logic error made when creating if statements is to use a single equal sign when you mean to compare. I forgot last year to update this because we discovered last year that in C#, if you use a single equal sign in an if statement, you get a syntax error. But that's C#. So C# does not make it difficult. It does not do things. It helps you out. It's the only language, curly bracket language, that I know of that doesn't allow a single equal sign. A single equal sign means assignment, right? Take whatever's on the right and move it into the left. C#, other curly bracket languages will do that for you if you put it inside an if statement. But if you're in an if statement, you don't want assignment, you want comparison. So it does the assignment, and then it looks at the answer and says true or false and goes merrily on its way and usually screws up your program. Microsoft and C# has decided you can't do that. I'm not even going to let you. Even if you meant to do it, it was a stupid plan. Don't do that. And in C# you can't. So that's a good thing. And you can cross out whatever you've got there. C# helps you out. Will not let you accidentally put an equal sign in your condition. That's good. This is not equal to. It's an exclamation mark. Other languages use less than, greater than combined like this. I can't see it in the recording, but the less than sign on the left and the right with the open ends together. But in our language, in C#, it's an exclamation mark equal sign. There's also a greater than or equal to and a less than or equal to, and we saw that in our design. We said if the price of the object is less than or equal to my savings balance, then buy it. That's different than is it less than. So you have to use those wisely. There are no spaces in between these last 4. They may look like it a little bit, but there's no spaces in between those. That's a syntax error. This is one operator. Whenever you use these, you must have an operand on both sides. It's like multiplication. In a calculation, you can't just have a multiplication symbol and one number. It doesn't work. It has to be a number on both sides, an operand on both sides. When you're comparing two things, how can you compare two things when you only have one? This will have a little more meaning a little later on when we do compound conditions, because some of you will intuitively use shortcuts that don't work. Whenever you use a greater than, a less than, an equal to, there's always something on both sides, a variable or a number. These always evaluate to true false. They all, 6 of them, have the same order of precedence, and they all come after, as I mentioned before, the mathematical operators. So if you have a condition that includes math, like we did in our design, the math gets done first. Order of precedence applies in there. Multiplication before addition, subtraction, parentheses. You can always add parentheses. In your pseudocode, when you pseudocode this, you don't put double equal signs in your pseudocode. So try not to do that when you're doing your conditions, when you're designing your programs. We can mix them. We saw that. If the amount plus the amount, that gets added because plus has a higher order of precedence than greater than. Both of these get done first. C# in its little scratch pad, wherever that is, keeps track of that total, keeps track of that total, then compares the two totals to see. Just for the purposes of that if statement. The totals are never stored anywhere. Perfectly acceptable. Order of precedence. Some programmers prefer to make that a little more readable by putting parentheses around it. Perfectly acceptable. Just like in math, you can put extra parentheses in, doesn't hurt anything. Sometimes it improves the readability. But they are not required here. Somewhere along the way, this paragraph got lost. It may be lost in your notes. If your notes start right here with if then else, is that where they start? Somewhere my simple if got lost. But how do we do this in C#? How do we do it? If statements. If statement, the command is a lowercase if. Doesn't say that here, I need to add it. So the command is a lowercase if, and the condition is surrounded by parentheses. I'll show you examples here in just a second. So whatever that condition, A less than B, age greater than 65, that condition needs to be in parentheses in C#. Then you use curly brackets around the true part, unless there's only one statement. I try not to use that example too often, but it's good to know sometimes. If there's only one statement after a condition, you don't need the curly brackets. Curly brackets surround blocks of code. A block is defined as more than one line, one command. So if there's only one command after the if, you can just type it in there with no curly brackets. You'll see me do that every now and then. If there's code for the false side, then you include an else, lowercase. Just like pseudocode, if there is no code for the else, you don't include the else. The code for the else gets curly brackets. Unless there's only one statement, then you can leave them out. C# allows you to enter else if with a space. That's not a command though. It's actually an else immediately followed by another if that's not indented underneath it. It's on the same line. Because of this, if there's only one statement, because of that rule, we can put else and if on the same line right next to each other. The if itself, all of it, everything in the true, everything in the false, the entire if is like this package. It's one command. So this is really an else followed by one command, another if. Don't need curly brackets for that. Makes it read nicely. Again, if you don't have code for the false, leave it out. So here's some examples. Whoa. There we go. If. What's that? BLN. What do you think that's a prefix for? Boolean. Okay, that's a very common prefix for Boolean. Notice here there's no relational operators. Well, Volker, you said whenever you use the relational operators, you have to have something on the left and right. That's true, but I'm not using a relational operator here. This is a Boolean variable. What does it contain?
True or false.
True or false. So this if condition contains either true or false, whatever's inside there. If this variable contains true, we do this stuff. Notice the curly brackets. I like to put them up here. When I type some code here in a minute, I'm going to show you alternatives. Other people like to move the curly bracket down underneath here on the next line and it sits there all by itself. Seems like a waste of a line to me, so I don't put them down there. Here's the end curly bracket. This curly bracket matches up with that one. They're not stacked on top of each other. I do that on purpose. Else, if it's false, if this variable contains the value false, then we display this message. So this Boolean test is a true false. Somewhere along the way, I've decided whether I have a test tomorrow or not. I stored it in there and I set that as true or false. If I have a test tomorrow, then I study for it. Otherwise, I watch a movie. Here's my end curly bracket for the else. And I always mark my end curly brackets. As you'll see, as we get deeper and deeper, you're already starting to see it. You're going to have end curly brackets all over the place. Gotten plenty of emails already. Here's my program. I don't know what's wrong. They either lost a curly bracket or they got an extra one in there. That's why I tend to label mine so they don't get lost. It's optional. It's a comment. But it helps improve the readability and helps you keep track of where's the end of this if. Remember in pseudocode, the else and the if lined up. Here they kind of do the same way. There's just a curly bracket in the way. And there is no end if command. In C#, there is no end if command. That's why I put the comment there to make it obvious that this is an end of my if. Later on, we're going to have curly brackets that are ends of loops. We already have curly brackets that are ends of methods. I tend to mark them all. So I know which one I think this is. And I like it when you do it. If you ask me for help and you got curly brackets all over the place, first thing I'll probably do is start labeling them and try to figure out, oh, look, we've got two of them here that belong to the same if. Oh, we're missing one. By labeling them, it makes it a little easier to track down the missing ones. Here's another example. If the temperature, you can put literals in your equations, or in your conditions, excuse me. That's legal. But what's magical about 72? Well, that's the lowest temperature that we'll use for opening the pool. Could that change? Yeah, that'd make for a good constant. Again, the curly brackets are all there. Here's the else if. If, notice the double equal sign. The text double equals red. Stop the car. Else if the text, notice it's another if. It's just another if statement, so we need parentheses around the condition. And then a curly bracket, curly brackets all over the place. And notice how the indentation shows the ownership. And also, as my comment says, note there's only one end if. Even though there's 1, 2 ifs here, there's only one end if because it's an else if. At least that's the way I treat them, and I stack them on top of each other. Here's my nested if example. Remember that big ugly flowchart up above? It looks like that one got lost somewhere. It needs to be pushed over. Because notice it looks like it's after the if, right? Indentation says do this, do this, do this. If there's no indentation, then they're sequential. And so this is next. But not really, it's part of the true part. So somehow I lost my tab there. I need to push it back over again. If the years of service is greater than 2, then ask a different question. Remember that flowchart. If the sales amount is greater than 5,000, then give them this commission or that commission. Else, again, the indentation critical. 2 end ifs in a row. If you wish, I do this occasionally, you can designate which if it was. This was end if sales amount. This is end if years of service. But just labeling them makes a big difference. So the key part of if statements in C#. Lowercase if, parentheses around your conditions. All of these curly brackets, believe it or not, are optional. Because the rule is if there's only one statement that follows, then you don't need the curly brackets. This, in C#'s mind, is one big, huge statement. The only place it's not one statement is right there. I'm sorry, I said all the curly brackets are optional. Those two are not. Because here I got 2 commands inside the else. So I have to have curly brackets. If there's only one command, you can skip them. The risk of skipping them is when the maintenance programmer comes in, adds a new line of code, doesn't see the curly brackets are missing, they may cause problems. Most programmers will tell you put them in. I break that rule occasionally, often just to show you. You'll see it on the web a lot where they have if statements without the curly brackets, and you'll go, that's not right. Yes, it is. So let's try this. We've got our trusty dusty design. Here's our design where we have to get some stuff and then figure out, and actually I'm missing some things, aren't I? I didn't get the other gets. I still have to get the credit card balance and I still have to get the credit card limit. I'm missing those. I will add them to the flowchart before I post them up on OneDrive. because we expanded the flowchart, but I forgot to expand my gets. But I've started writing this, or at least I've got the screen layout. So here's my screen layout for this, where I just get that information. I've got a clear button that clears these out, and I got a help button that helps me decide whether I should buy this or not. And I'm going to follow the flowchart. So inside button help here, I'm now going to follow my logic. The first piece of logic says get your inputs. Right? It says get the savings balance, get the price, or the item price. Well, it says price, I better follow my design. Did I follow it all the way through here? Yep. So we have savings balance and price and credit limit. I need to transfer those in first from the text boxes. So I'm going to transfer my inputs. I'm going to try to give you a good example here. Transfer my inputs. The first one I want is the price. The price is equal to, no, come on, price. It said, never heard of it. Why not? I haven't done my overhead yet. I have to declare my variables. Price is going to be a decimal, right? And while I'm at it, I'm going to need a few more, like another decimal for my savings balance. And another decimal for my credit balance. And finally, another one for my credit limit. All of these are money amounts, so they're all decimals. Okay, now I should be able to transfer my input. Now it's good. Oh, that price. Price equals whatever's in the text box, and the text box is called item price because I did that earlier, dot text. Can't do that. All of you know why, because I cannot transfer a string into a decimal, so I have to parse that. And now it's happy. What else would I potentially do to that? There's a price. Unformatted. Right? It might have dollar signs in it, right? Those guys back there were buying $10,000 TVs. That's going to have commas in it. Right, so I might want to unformat it, but I don't have Volcker tools in here, so let's review that real quick. Hopefully I still have it on my desktop. I'm going to add an existing item. That should be on my desktop. There's Volcker tools. Done. And now I can unformat before I parse. vtools.unformat. Extra parenthesis on the end. Now I'm going to copy that 4 times, and you guys are going to help me make sure I don't screw this up. Because everything that I'm bringing in is a decimal. Everything could have dollar signs. Everything needs to be parsed and unformatted. Just need to change the names. And then who knows what I call them. Savings balance, credit card balance. Probably would have been better to name that credit, but too late now. And credit card limit. Okay. Now here's where we would normally do calculations, and we're kind of doing calculations, but determine whether to buy, whoops, or not, and how to buy. See that pink squiggle? I still don't understand why I'm getting a whole lot of method descriptions, a whole lot of program description, project descriptions, form descriptions with errors in them. If you don't have the spell checker installed, it's a lifesaver. Install it so the pink squiggles catch your eye, hopefully. Now I follow my design. My design says, first ask whether the savings balance is greater than the price. I'm going to solve this both ways. So this first one I'm going to use nested if so you can see what it looks like. If the savings balance is greater than or equal to, is that what it said, the price? And again, follow your design. I already thought about it. Greater than or equal to the price. If your design is wrong, fix it. Curly brackets. This is something new in Visual Studio 2013. As soon as I type one curly bracket, it gives me the closing one. Thank you. Because forgetting them is nasty. I'm going to move it down to the next line, and notice when I do that, it automatically gives me a blank line and moves it down and lines it up, but leaves that one up there. So don't let that end curly bracket bother you. Notice it's also automatically indented me. I didn't do that. What am I supposed to do? At this point, I'm supposed to display, so I'm going to use a message box to do all my displays. And you know what? While I'm at it, let's do a fancy message box. Message box can have up to 4 or 5 different components to it. The first thing is still the message. What was it? Just buy it, right? Exclamation marks. Then you can designate a title. Oops, I forgot the dot show. That's why I'm not getting any help here. Notice underneath it's helping me. First thing it wants to know is message box. It's not helping me much here. What's the message? And then what's the title? This is my app advice. This is my title. Then which buttons do you want? And I think we have put in here message box buttons. I just want an OK button because that's not a yes, no, it's not. It's just an OK button. And then finally, you can ask for the message box icons. And this one isn't helping me very much. Message box icon. In my notes for message boxes, it tells you the different kinds of icons. They're also right there. Some of those overlap. They have the same information or the same icon, same picture. What I'm going to use here is an information icon because this is not a error. That's another kind of icon. It's not a warning. It's another kind of icon. It's just an information icon.
We made an exclamation.
It'll give this one for information will give me an I. Right? But the exclamation is actually the same thing as a warning. A lot of them overlap. Okay, did I follow my design here? Buy it with cash. No, I did not. Buy it with cash. Okay, that's my true part. Now, the false part. Another curly bracket, enter, thank you very much. What do I do here? Follow my design. What do I do? Ask another question. If the credit limit minus the balance is greater than or equal to the price. If the credit limit minus the credit balance is greater than or equal to the price. Notice the indentation. It's an if inside of an else, not an else if. It's a little bit different. We're going to do the else if next. If it is, curly bracket, there's your twin. What do we do? Another message box. Pasted it, automatically indented. Still got the same advice, still have the same icons. The only thing I'm going to do here is say buy it with credit, if I remember right, or just charge it, I forget. Let's go look at my design, charge it. And then another else. Now I'm doing the false part. So else. I've had students in the past who prefer to do the if and the else and the curly brackets all at once, and then they plug in the true and the false. I'll try to do that on the next one. Like this one. Now what? False. And you got to keep track of where you are in this flowchart. Sometimes it helps to click and select where you're at. I'm here. I just did the true part. Now I need to ask another question. Credit limit minus the balance plus the savings. So I need to ask another question. If, parentheses, notice even the end parenthesis was added for me, plus the savings balance is greater than the price. And again, I could add extra parentheses here. Here's my curly bracket. What happened? Did I lose my curly bracket? Because this one, see how they line up? That's really helpful. I never asked for one here. Curly bracket, else curly bracket. Now I just fill in the trues and the falses. And now I'm supposed to say clean out savings and charge the rest. And finally, one more message box that says walk away. And this time I'm not going to use an information icon. This time I'm going to use the exclamation icon, or I could use the warning. And I'll get a different icon for that one. So notice how that kind of has this waterfall effect. If, else, if. It keeps working its way in. And what if I had two more credit cards to deal with? Could get complicated. But let's test this, because this is my logic. So before I convert it to else if, let's test it. Okay. And let's have a $5,700 TV and a savings balance of $5,800. I have to put numbers into all of these because I didn't put try catches around here. What would have been even better is to write some code to say, if the credit balance isn't there, then don't worry about it, because you didn't enter it. But then I'd have to write different logic down here, because if you didn't enter it, I can't use it to help you decide whether to buy the TV. Oh. Making things real world, you end up being like Rachel, oh my God. Design it, get a cocktail napkin out, start drawing flowcharts. What are the questions and how do you deal with them? So here, I'm going to say my credit card balance is $3,200 with a limit of $10,000. It should tell me to buy it, right? With cash. Buy it with cash. Notice the information icon. Notice the title across the top. Your message still comes first. All the rest of that stuff's optional. If you don't include it, you get an empty title bar. You don't get an icon, and you get an OK button by default. Okay, so now I can experiment. What should happen there? Buy it. Cool. I like to test my boundaries. It's kind of like my kids testing their limits. Right on the limit, does your program work? Just above it. Whoa, it says walk away. That doesn't sound right, does it? Because I have a charge card balance of $3,200, $1,000 limit. I'm already overdrawn. Program's smarter than I am. Now it's $10,000, and it says charge it. Because I have enough room on my credit card. Again, we can test it. We need, let's make it simple, $5,000. We've got a limit, $5,000. Sure, the credit card company will be really happy that I'm right on my limit, but shouldn't be a problem. Buy it with cash. Oops. Charge it. So even though I'm right on the limit, but if I bump it up by one, clean out the savings account and then charge it. And then the only way this doesn't work is if I have a charge card balance that is nice and high, like $9,500. It's only $500 left. Add that to my savings. walk away. Notice the icon changed. So my if statement's doing all kinds of things for me here. It's helping me decide whether to walk away. It's also helping me decide the icon. Do you see redundant code here? I kind of do. What's the difference between this and this and this? The message, right? Just the message. So I might be able to simplify this a little bit. Okay. And if I can tolerate the same icon for this one, I can really simplify. What I'm going to do is create a string variable called message. And instead of doing all of this fun stuff over and over and over again, I'm going to say that the message equals buy it with cash. And that simplifies my code quite a bit. And then underneath, and I didn't mark my ifs very well, did I? This is the end if for use all. This is the end if for credit plus savings. This is the end if for cash. Who cares? And this is the end of my method. End of, what's the name of the button? Help click. Who cares? Well, I need to display my message box. Is that what you're going to tell me? No, go ahead.
How do you know?
How do I know? Because of who they line up with.
Oh, okay.
Okay, this one lines up with that one. So this is cash only. This one, and I probably should have marked them right away. If I was building these the way I built that last one, where I did an if, and then immediately put in the else because I knew it was coming, then the end if was there. I should have marked it right away. Right? How do you know they should line up? But what if you somehow mangle them? Now, I promised you I was going to look for this, and I forgot. I was wrapped up in something else. But I think it's here or there. Let's try edit. Advanced. Format your document. That lines everybody up in the Microsoft approved way, which is pretty dang close to mine. Notice how that shifted back and all my curly brackets line up. So if you ever get this so it's messed up, and I've seen some of these end curly brackets where they're messed up, edit, advanced, format. And it'll clean them all up for you. But I think it's worthwhile adding them now because what do I want to do? I want to display a message regardless, so it has to be after this curly bracket. Remember my note said if you have redundant code, the same code appears in every single case. Every single if, true, false. Every single one of them did a message box. Now granted, initially one of them had a different icon. And I'm losing that in this example, but I can show you that I can do the message box with the message, whatever it is from up above. The title's the same. The OK button's the same. Notice now that I did the show properly, it's giving me message buttons.OK and message box icon dot, what was it, information. In Unit 5, I'll require that all your message boxes be complete, at least those 4 parts. Unit 5, not 4. You can do it in force, no problem. So now I've changed it, I better test it. But notice how clean this is in the if statement now. And there's only one message box that was cluttering everything up above. And it wasn't terrible, but this is better. And this is where I'll throw some advice at you, saying you could simplify by moving the message box out of the decision, out of the if statement. I had to add an extra variable, but it really cleaned up my code. Give it a quick test. Should be able to use cache. Charge it. Mix it. Oops. What? Oh, I've got a 5. That's the wrong way. Smarter than I am. Charge the rest, and finally bump this back up to 9,500. And didn't say walk away. Clean out, say, oh, this is too high. I'm pretty confident my app is going to give me good advice. Doesn't mean I'm going to listen to it, but I'm pretty confident it's going to give me good advice. Now, finally, how would this look if I converted it to an if statement? Or else ifs, excuse me. So Control Q, there's a way to comment these out. I always forget, every editor has it differently. Comment, 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 nothing there. I know there's a way to do it. Comment selection, oh, that's way too complicated. Oh, I have my own button for it, dummy. Okay, so this is the nested ifs version here. And here's the else ifs version. Okay, what happens here is the curly brackets go away and the ifs come onto the same line. The curly brackets after the else go away, which means I'm going to have some extra curly brackets when I'm done. And my indentation, and I'm curious to see how when I format this, if I clean it up, what happens. If I do the format document on this, it might indent them all messy again. So this is my end if, and there's only one. It's one big if in my mind. So this is an end if, this is an end if. Now I don't need them anymore. That's what it looks like with else ifs. A little cleaner, don't you think? I think so. If you can get your head around, it's basically the same question. Do I buy it or don't I? Or what's the message in this case, right? What's the message? And then show it. Should give me the same results. I haven't really changed anything. Do it again. Still works. But also notice where I did my testing. When you start throwing if statements, particularly if they have numbers like this, where we're going savings greater than or equal to, credit limit minus the credit balance greater than, test the boundaries. Because if you accidentally leave out the equal sign, or you accidentally put one in where it doesn't belong, or you flip your decisions from less than to greater than, they won't work. They might work 90% of the time until you test the boundary, and then all of a sudden it doesn't work. When the price of the TV is $5,000 and you know you got $5,000 in savings and it tells you to walk away, you're not going to be happy with your app. You're going to go look for a new app or reprogram it and fix it. So test it thoroughly. Questions? The else ifs tend to look better in flowcharting and they tend to look better in code, but they don't always apply. Think about the example that's in the notes. This is not an else if. This is not an else if. Else, it is an else if, but it's not the same question. It's a different question. You shouldn't merge them. If you're not sure whether you should merge them or not, ask me. But usually an else if is an if, else another if, else another if, else another if, until you get to the last choice. If there's anything else in between, it might not work as an else if. If you're not sure, ask me. All right, let's stop there for today. When we come back on Wednesday, we're going to give you a chance to do some of this, and then we're going to go into, well, let's talk about this real quick. Comparing strings. Comparing strings only makes sense for equal and not equal. Why would I compare string 1 less than string 2? What does that mean? Alphabetically. And actually, it's not even alphabetical because all computers behind the scenes use an ASCII character sequence or a Unicode character sequence. Most of you have probably already heard of it, but I think I have a link still in my notes. Every single character that your computer can represent or use is assigned a number because computers like numbers. So every single letter is assigned a number. The capital letter A is decimal 65. A little letter A is decimal 97. Every letter gets a different value assigned to it. And these are standard across all computers. And we can bring in the special characters with the dollar signs. They all have values, but notice where they appear. We can bring in extended characters with European symbols, and it goes beyond this even. This is just the ASCII character code set. This has been expanded to the Unicode character, and it's got all the Japanese symbols in it, and all the Korean symbols, and all the Chinese symbols, and all the symbols in the world. So far, with room for more. Every one of them is a value, so when you say, is this string less than that string, you're asking on a character-by-character basis, is this letter less than that letter? If it is, or this character less than that character, if it is, then we're done. If they're the same, we go to the next letter, and the next letter, and the next letter. The only reason you do that, compare strings using less than or greater than, is to sort them. And in the past, that was a nice exercise. But in today's programming world, if you have a whole bunch of strings, they're usually stored in something called an array, and all arrays know how to sort. You don't have to do it. You just tell them to sort, and it does it. So when you're comparing strings, all you're really worried about is, are they the same or are they different? And that works. If you really need to do this, read my notes, but you probably look at, isn't that ugly? In C#, you cannot put a less than. This is not legal. It is in other languages, but it's not in C#. You have to do this string compare thing, which goes all the way back to objective or just regular C. And who cares what it does because we're not going to use it anyways. There's the ASCII table. According to Wikipedia, Unicode currently has 110,000 different characters in it. But it's got room for 4 billion, so we got room for a few more. Bring some aliens in here. We can handle them, no problem. What's interesting is the original ASCII characters, are only 255 of those that I showed you on that webpage, are at the beginning of the Unicode, so they all have the same numbers they had before. Okay, that's where I want to stop. Sorry for the extra couple of minutes, but comparing strings, you can do it. Comparing dates, you can do it. When you come back next time, you will do it.